So the question says, how many pairs of sets S, T are possible among the subsets? 1, 2, 3, 4, 5, 6. Okay. That satisfy the condition that S is a subset of T. So S is a subset. Like if I assume that this is my T and this is S, right? So what would be the pair? How many number of pairs are possible where I can say that S is a subset of T and these are the numbers that I have. So there can be numerous, possibilities. So let's just start with one. For example, if I have 1, 2, 3, 4, 5, and 6. Okay, I'll just write them. So there can be chances where I have all my 6 numbers in set T, as in inside of T, 1, 2, 3, 4, 5, and 6, and none in S. So this would mean that out of 6, there are 0 in S. Hmm? Similarly, if I erase this once, yeah, and I say that out of those 6 numbers, 1, 2, 3, 4, 5, 6, any one of these are to be here. Any one. It can be 1, it can be 2, it can be 3, it can be any of the 6 numbers. So 6C1, out of 6, 1 is chosen. Similarly, 6C2, any 2 can be chosen. Hence, we'll have this till 6C6, where in this case, all the 6 numbers are present inside this, inside S, and S is a subset of T. Okay, let's write down this thoda systematically so that we understand what is going on. So, how many numbers would be present in T? How many would be present in S? And what is the selection criteria? So, if I select 0 out of 6 numbers to be present in S, it would be 6C0. Huh? If I select 1, it's going to be 6C1, right? If I say that 2 numbers are going to be selected, 6C2, 6C3, 6C4, 6C5, 6C6. All the possibilities I have written it down. And just write down this thoda properly. This is all in T, none in S. And this one is all in S, none in T. And these cases are some in T, some in S. Okay. So I would want to break this down. So do you know how to break these? So this one is going to be value 1, right? Because 6 divided by 0, 1. Now 6C1, 6, and this one 1. So hence 6. 6C2 would be 6 into 5 divided by 2, 15. 6C3, 6 into 5 into 4 divided by 3 into 2. So are you able to understand what I'm doing this? So if a number says 6C1, for example, this means that 6 is going to start and end at just the first number and the second one. Okay? If it's 6C2, what's going to happen is 6 will start and end at the second number in a decreasing order. Okay, 6 into 5. And the lower digit is going to continue till 1. Okay, hence 15. 6C3 similarly will end at third number 6 into 5 into 4, and 3 will continue until 1. Okay, so how much would this be? Calculate karo. Try to solve for all the rest of the numbers. Okay, pause the video and solve it, and then check whether we are going on the same page or not. Okay, so 6 3 is done. Then we have 6C4. So I'll start from 6 and end up till the fourth number. 6 into 5 into 4 into 3. And from 4 I'll start and end until 1. So this will give me how much? 15. Six C5 will give me 6 into 5 into 4 into 3 into 2 divided by 5 into 4 into 3 into 2 into 1. Okay, this is going to give me 6. And 6C6 would eventually be 1. Okay, I hope this one part is clear. So now, yeah. So in this first case, we said that 6 is in T, and how many are there in S? None. So I'll be writing that 6 are in T, 0 in S. Similarly for 6C1, 1 is there in S and the rest here. This is going to continue. I wrote the opposite. Clear? Now, why is this important? It's because, let's again take an example. If we have two numbers in a set, how many subsets are possible? It can be 1, it can be 2, it can be 1 comma 2, or it can be 2 comma 1. So a total of 4 pair of four, right? So this has one formula, 2 to the power n, where n is the number of elements here. So this also gives 4, right? So what is the final question that we have been asked for? How many pairs of sets? Okay. How many pairs of sets are possible for these elements? So our final equation would be a combination. So this particular question is very nice because why? Because it's a combination of permutation, combination, and sets. So what would be our final equation? It's going to be this multiplied by the number of sets 2 to the power 0, again 6 into multiplied by 2 to the power 1, this into 2 to the power 2, this into 3 to the power 2 to the power 3. Okay. Similarly for the rest of them. So after you do this, you'll get 729 as your answer. Is it clear? What we did is the first part of the question, we tried to see how many, you know, combinations can be made to find the number of sets. Okay? Which satisfies that S is a subset of T. And then after we found out the number of, combinations that can be made to satisfy this particular statement, how many sets are possible then in all the cases that we try to do? Okay, after doing that, we submitted all of them and then we found that a total of 729 pairs of sets can be made. Clear?